Hi folks, we're going to take a look at page 84, number 26. So this is, I'd say a little more difficult a problem. So they're giving us this relation here. Okay, so this may or may not be a function. Notice that this is given in a different form. The y variable is not isolated. Okay, so of course we've seen this before, say with the equation of a circle. Okay, and they're talking about a general point on this curve. Okay, so they're not specifying a specific point. They're saying let P be any point on this curve. Okay, and they want us to show that the slope of the tangent is given by this expression here. So just to give you a heads up that towards the end of the calculus portion of this course, we're going to see a more elegant way of solving this this problem. Okay, so here we don't really know how to deal with an equation of this form. So we'll see if we can solve for y to put it in a more familiar form, okay, form where y is isolated. So let's see what we can do. So here we'll keep root y on the left hand side and we'll bring root x to the other side, and here I realize, well, I can square both sides, okay, to get rid of the square root around the y. Okay, so if I square both sides, I end up with y here. Now, of course, when I do this, I have to keep in mind my restriction on y. Okay, remember y had to be greater than or equal to 0. Here you don't see that restriction anymore, so we keep that in mind. Okay, and now let's square the right-hand side. So we have 1 minus root x times 1 minus root x, since I'm squaring it. So let's simplify this here. So we'll just FOIL this. 1, okay, minus root x minus another root x, so minus 2 root x. Okay, and then negative root x times negative root x, so that's just plus x. Okay, so we need to show that the slope of the tangent is given by this expression. Okay, so how do we find the slope of the tangent to a function? Well, we take the derivative. Okay, now luckily in solving for y, we actually got an expression for which we know how to take the derivative, because these are all just powers of x. So we have the derivative is given by, well, derivative of 1, that's just a constant, so the derivative is 0. So here we've got negative 2 times root x, so it's negative 2 times the derivative of root x. So root x, remember, is x to the 1/2. So this is going to be 1/2 times x to the, well, subtract 1, negative 1/2. Okay, and then here we have plus the derivative of x, which is just equal to 1. Okay, now here I notice that I could just stick the x value into the equation, but somehow my answer needs to also incorporate the y value at this point. Okay, so clearly we're going to have to do some algebra to make this work out. So let's see where it takes us. Not sure where it's going, but let's see where it takes us. So here we've got the 2's which reduce. So I'm just left with, well, negative 1 in the numerator. And here, bring this down to the denominator. So we have x to the 1/2, okay, plus 1. Okay, still not really seeing where this is going. So let's do a little more work. Let's bring this to one fraction. So here, common denominator will be x to the 1/2. So I have negative 1 plus 1 times x to the 1/2, okay, over x to the 1/2. And let's clean this up by putting this in terms of square roots. Okay, so here we have negative 1 plus root x over root x. Okay, now this looks a little more interesting. So I want you to look at this expression here. Well, look what I have in the denominator. I have root x. So if I were to input the x value here, I'd have the square root of a. Okay, look at what I'm trying to show. Well, in the denominator, I've got a square root of a. Let's take a look at the numerator. Okay, well, if you look very closely, this looks a lot like my formula for square root of y before I squared both sides. So if I just want to show this very explicitly here, well, this is 1 minus root x, this is negative 1 plus root x. Let me factor out a negative 1, and what am I left with? 1 minus root x. So this expression in the brackets, well, hey, that's just equal to root y. So I can replace the expression in the bracket by root y. Okay. Now, using my exponent properties, essentially, since square roots are exponents, I can rewrite this as negative square root of y over x. Okay, so if I want to find the derivative, okay, now this is a notation I think I've shown you once, okay, I'll bring it again, is that when you want to define a particular point or even an x value that you're evaluating a derivative, okay, I can just put it here that I'm evaluating it at the point AB. Okay, so this means the derivative of y evaluated at the point AB. And so now when I put that into my equation, I get negative square root of y over x, so b over a. Okay, and there you have it. Okay, so like I said, we're actually going to see a more elegant way of solving these types of problems, but the way we did it here was to take this equation in an unfamiliar format and rewrite it in a more familiar format so that we could then take the derivative. Okay, and here we had to be a little clever in order of rewriting it so that it also contained the expression for y. Okay, that's it for this one.